The idea of building a lunar outpost has long captured people's imaginations, but what would it really be like to live on the moon, and what will humans do there? The moon's gravity is only 1/6 that of the Earth's gravity. A person who weighs 150 kg on Earth while wearing a spacesuit will weigh 25 kg on the moon. Lunar days stretch for about 14 Earth days with average temperatures of 123 degrees Celsius, while lunar nights also last 14 Earth days and maintain a frigid cold of -233 degrees Celsius. About the only place we could build a base that wouldn't have to deal with these extremes is near the lunar poles. These areas likely store vast amounts of water ice and enjoy low levels of light from the sun for several months at a time. Instead of the blazing heat of lunar noon, it is kind of a perpetual balmy sunset with temperatures around 0 degrees Celsius due to the low angle of the sun. NASA says that humans will be living on the moon by the end of the decade. The Artemis mission is the first step toward a sustainable presence on another place in our solar system. Artemis Base Camp would be located on the moon's south pole. Improved spacesuit designs, better cameras, and better equipment in general will make it easier to gather information and explore the moon's surface than it was 50 years ago. With lunar roving vehicles, they will search the planet for ice that can be filtered into drinkable water and hydrogen that can be converted into fuel. There could be habitable mobility platforms that crews could use to visit other locales on the moon for up to 45 days at a time. Much of the science that researchers want to do there could help engineers learn how humans can use lunar resources to develop a sustainable colony. It could also test out new architectures that will be important to going to Mars. Beyond that, there is interest in learning more about the moon's geology and interior, how it's changed over time, and what its origins can tell us about the history of Earth and the solar system. The lunar rock records of over billions of years could give us new information about violent events, including supernova explosions or asteroid strikes that may have caused past mass extinctions on Earth. The moon offers a perfect foundation for telescopes to look deeper into the universe. Crews on the moon will be able to drill down into the ground to see whether water ice can be found at shallow depths. Astronauts will also grow plants on the surface of the moon, observing their ability to photosynthesize and grow, and how they respond to the stress of lower gravity and space radiation. The lunar soil is potentially rich in other resources such as oxygen and silicon, which are present in large quantities, but also various metals such as aluminum and iron. The most valuable might be helium-3, which could serve as a future fuel for relatively safe nuclear fusion energy. Helium-3 has been implanted by the solar wind into the lunar soil over billions of years. Longer stays on and around the moon than those of the Apollo-era missions will help scientists understand the effects of deep space travel on astronauts. They will be able to assess whether space radiation shielding is effective and how astronauts react to working in space for extended periods. The astronauts may even be able to fuel up for their Mars trip with moon-made rocket fuel. It's an ideal launchpad for missions to Mars and other worlds, and for some people, it's the ultimate tourist destination. By successfully establishing a presence on the moon, we will enhance life on Earth and prepare to explore the rest of our solar system and beyond.